everyone. We're going to be on to the last PyData talk of today. But after this, we'll have the keynote and the pitch, which will also be awesome. So today we are hosting Dmitriy Pastushenkov and also Adrian Boguszewski, and they are both AI evangelists at Intel. They also had a booth, which actually was kind of a spoiler to this talk, because they're going to be discussing an AI PC, which is a single machine that can run generative AI. So I'm really excited to learn more and give it up for them.
Thanks. Hi, everyone. I am Adrian, AI software evangelist at Intel. I'm together with Dima. Dima is also AI software evangelist. And today we would like to prove you that you can run AI inference, any AI inference, GenAI or conventional AI inference on this simple device like this laptop. So let's start. There are many client AI use cases like voice recognition, super resolution, denoising, depth estimation, which are kind of conventional AI cases. But we also have quite new AI cases like chatbots, meeting summarization, code writing, text to image, and anything like that, what we call generative AI. And what's the difference between two of them? So if we compare them, conventional AI usually output prediction based on input and the model. So we add them some input like image or text or anything like that, and we expect the same output for the same input. And the model size is quite small, right? The model is like from 1,000 to hundreds of millions of parameters, and inference runs continuously in the background. So for example, when you run on web stream cam, for example, or webcam stream and something like that, so you can see frame by frame and the output is generated constantly. And the latency for that, which is required, is quite low. We need to have the result as soon as possible. But comparing to generative AI, when we can generate unique content like text, music, image, video, and so on, the model size is quite big. It's billions to trillions of parameters, so it's a heavy model. At the same time, we interact with the model, so it's not running on our webcam stream or anything like that. We interact it, prompt it, and so on and so on. And at the same time, the higher latency accepted because it's okay to wait just 5 seconds for the output, right? Or even half a minute or something. It depends on the case, right? So these are differences between conventional AI and generative AI. And I'm gonna prove you that you can run any of them on this single laptop in a while. But first, what is AI PC? Because we call this laptop an AI PC. And why it's called AI PC? Because there are 3 AI engines in this Intel Core Ultra. There is CPU, just usual CPU like you use in your laptop, which is good for fast response cases, low latency AI workloads, and so on. This is core. But then we have also integrated GPU. So it's not a discrete, expensive GPU card. It's a simple integrated GPU, but quite powerful. We will show you that in a few minutes. And this is good for high throughput for AI accelerated digital content creation, gaming, everything like that. But it's not all. We have also their NPU, something which is called Neural Processing Unit, and it's for power efficiency. So it's a low power device to deliver AI workloads on and AI offload for battery life. So it's running low power constantly in the background, for example, blurring your background or detecting people. That's the best case for that kind of device. And I'm gonna show you this also in a few minutes. So if we look back at the AI use cases we had conventional or generative AI, it looks like we can run depth estimation on NPU, for example. So we have CPU for something else, we have GPU for something else. We can run also depth estimation on CPU. Then in that case, NPU will be free for something else and GPU as well. Chatbots, as they require a lot of computation, probably GPU will be the best choice. Text to image, we can connect GPU and NPU together. So we run some models on NPU in the same workload and some of them on GPU. And of course, in other cases, it looks like this. So all of them or any of them can be run on one of these devices or a few of them together. Okay, that was the theory. Right now, let's look at some code. So we are entering the software stack section, and I'm going to give the voice to my colleague, Dima. Dima, the stage is yours.
Thank you, Adrian. Thank you, Adrian. So great introduction to AI PC, but what is a software stack for AI PC? Because the hardware is not sufficient to have added value, right? We need to have also comprehensive software stack. And the software stack for AI PC looks like that. You can see in the middle that we have OpenVINO. And OpenVINO is our leading product, so it's AI inference toolkit, which allows you to work with models in, let's say, almost in any format. You can see on the left that OpenVINO can read PyTorch, Onyx, TensorFlow, and many others formats. And running these models on the Linux or Windows, it's possible to deploy the models on NPU, CPU, and GPU. And basically, this is very simple. So OpenVINO is a great toolkit for AI inference, and at the same time, it's very easy. There is a model as input. There is some information from sensors, and there is a result of AI inference. But there are also other popular frameworks on the market. I believe many of you heard about PyTorch, for example. This is, I would say, the most popular framework right now for AI training, also for data science, but not only. Sometimes also AI inference can be run with PyTorch. And this is also quite popular approach, and OpenVINO can work as a backend for PyTorch via Torch compile. So it means that OpenVINO allows to accelerate the applications which are written with PyTorch on Intel hardware. So without OpenVINO, the performance of such solution based on Torch is not that good as with OpenVINO. To utilize the power of Intel hardware, you basically need to add OpenVINO as a backend here. Another popular approach for AI inference, especially for GenAI, is Hugging Face. I believe also many of you heard about Hugging Face, and I believe also used. And Hugging Face is a kind of GitHub for AI models, right? So they host the models there. So there are many companies host the models there, like Microsoft, Meta, and so on. And there is a popular pipeline to run AI inference for that. And OpenVINO accelerates this pipeline via Optimum Intel. There is another good framework which is called Onyx runtime, so it's open source as well, and it also can be accelerated with OpenVINO backend. So, for example, if you have already application with Onyx interface, no problem to boost the performance of your application adding OpenVINO inside. It's also quite easy. So let's take a look more in detail about OpenVINO. OpenVINO is let's say it stands for Visual Inference and Neural Network Optimization. So, and the product is started as a framework for visual inference, but right now OpenVINO is for everything, basically for NLP, audio, LLM, GenAI, and so on. And you can see here that you get the models as input. When you optimize the performance of models, for example, it's possible to quantize the models. When you deploy the models to CPU, GPU, NPU, FPGA, you can see multiple types of Intel hardware like Atom, Core, Xeon, Intel Core, and even ARM. So you no problem to use OpenVINO on ARM platform, and it runs in Windows, Linux, and even Mac OS. If you have a MacBook, no problem to use it with OpenVINO. So we are on developer conference, right? So therefore I would like to show you some code and how to install OpenVINO PyData. So I believe you use PyTorch. When pip install OpenVINO, that's it. And the code looks like that. Import OpenVINO. When we just, for example, load some image as input. After that, we initialize the core OpenVINO, we read the model. In this case, it's in a PyTorch format. We compile the model. In this case, it's CPU, but it can be also GPU or NPU. And we've compiled model. We run inference, get the result, and that's it. So this is AI, very simple. Supported device, CPU, GPU, NPU, and you can also let OpenVINO decide itself which to use with auto. It will select for you what device is the best. PyTorch. For PyTorch, if you have already the application written in PyTorch, no problem to add OpenVINO as a backend. You can see just 2 lines of code. No many things to explain. Onyx, also simple here. So just you can install the package similar to OpenVINO, and then I just try to do it fast. You in inference session in PyTorch in Onyx application, you select OpenVINO provider. That's it. No code changes, but boost of performance. And another thing is Hugging Face integration. For Hugging Face, so again, it's installed with pip installed, and Hugging Face pipeline is pretty simple. So it's for LLMs. It's based on transformers, and so it's called auto model for casual LM. For example, with class and with Optimum, we just change the name a little bit, change the prefix. We import this class, and then we load the model from Hugging Face using model ID. When we get tokenizer, we create a pipeline, and we run inference like this. Quite simple as well. I don't like to provide you any complex code. Okay, but we have also something special for you, something very new. So recently, in the last version, we released OpenVINO GenAI library, which allows to run GenAI for workloads LLM even easier. And you need just like 3 lines of code, I would say. And here you can see that you just need to initialize pipeline, selecting the model path locally on your device and selecting the device for inference, and you can just run pipe generate, provide the prompt, provide some parameters, and you are good. You get already the answers from the system. So there is also stop flag possibility if you don't, let's say, if you'd like to stop the inference in advance, then so there are some possibilities for that. And if you compare now the inference with Optimum, with Hugging Face pipeline on the right side, and with such a new approach with OpenVINO GenAI, you can see that the code is just 3 lines of code, and it looks very simple, and this is very simple. But the most important thing is actually under the hood, because we are all developers. I believe we also can spend more time to run a couple of additional lines of code. But what we cannot do, if we take a look under the hood on Hugging Face pipeline, you can see the dependencies are quite huge. And first of all, if we use Hugging Face, we always need a PyTorch dependency, which takes, I believe, about 1 gigabyte. In total, all these dependencies to run a simple pipeline takes more than 2 gigabytes. But now, with this GenAI approach, we have no PyTorch anymore. It's just a simple, very short list of dependencies and about 2 megabytes on the disk. So this is, let's say, a really great advantage, especially, so I'm working with AI PC. And therefore, we see that it's critical for desktop development to have less dependencies to produce exe file or to produce setup. This is very important. So let's run the demo. Let's take a look how it works. And I need to change the mode. You see my screen? All right. Okay. So first of all, with OpenVINO, we have more than 100 OpenVINO notebooks, which are a great demonstration of all kinds of models. And I would like to show you LLM. So I don't go through the code in details. You can see just that there are many models from Hugging Face are supported here. So we select in this case Llama 3, what we do as well. So we quantize the model. We run it on an integrated GPU with int4 quantization. And yeah, so we compress the model, but I don't spend much time here, as we are limited with time. And finally, we start with Gradio, such simple chatbot on PC. And the point is it runs locally. So it doesn't require internet, it's all local. And if I try to communicate with it, I will ask what is OpenVINO. And I expect to get some answer. You can see that chatbot is answering, and the answer is reasonable, right? So, Adrian, I believe you can confirm, as you work since long time with OpenVINO. So, and the point is that I am able to run locally on the PC. I compress my model from 25 gigabyte to 5 gigabyte, and it's still accurate. So this works really great. So what else we can ask? For example, what to do tonight? In Eindhoven. To do, forget to. Yeah. To do. Yes. Is correct, right? Well, okay. Let's see what would be the recommendations. I don't know. I hope you can check the accuracy.
Does it know?
I believe so.
It does.
It's busy with that.
Yeah.
Now, yeah, it tries to take context from the previous.
Yeah.
Visit the page. Whoa! I didn't try it in advance, to be honest. So I also don't know. Explore the city. So visit PSV Stadium is done. So the next, explore the city center. Go shopping, enjoy live music, relax a cafe.
Hallucination there. Yeah, there's no Lafayette galleries in Eindhoven.
And FNR is an attraction park. No, I'm wrong. Sorry.
Okay. Yeah. So this is Llama 3 model. So it's quite powerful. They trained it on the huge amount of data. And so I encourage you to try this example yourself. We will provide some links about that. And I would like to show you also what is under the hood, basically without this fancy interface. How? Control plus. Oh, yeah. Thank you. Okay, so you can see here that LLM inference is very easy, actually. No rocket science here. So we have a LLM pipeline. We give the model idea. So this is basically where I store my model locally on PC. I select device, GPU in this case, and I provide my prompt to the function which is called generate, and I print it here. That's it. So this is, I don't know, so I believe it's possible to start also educate people in school with that. So very simple code, right? And how it works. Yes, you can see here that I have this chat sample already. I have a tiny llama in this case, and I can run it. Yes, question. Let us. With a tiny llama, I need to be careful because it's just 1 billion parameters, and so this is not the most performant model. Therefore, I will ask what is AI, and you see, it's very fast, and I believe the answer is also reasonable, right? Okay, so this is how it works. It's all local and it's all very simple. So, Adrian, back to you.
Yeah, thanks, Dima. But this is not the only thing we want. What we wanted to show you. I'm gonna switch to another demo because I already promised you to show you the performance difference between different devices and as well as power consumption. So what I'm going to do here, I'm going to run object detection model, which will run with my webcam, and then I'm gonna show you how performant it is. So let's start with CPU first. Yeah, so it's running here. You can see that there are, person detected in the background. 700 frames per second running just on CPU, nothing else. 700, really pretty nice result, right? We can see it's running on CPU right now. We can see the power CPU utilization, and we can look at the power usage. So right now we're using about 40 watts. 40 watts running on CPU. So it's quite much power, right? So maybe we can go better with something else. So let's switch to another device. The next device will be GPU. So in this case, we expect even more frames per second. And then let's see also power consumption. So right now I can see more than 1,000, 2,000. Yeah, right now, you know, the measurement error is very important, right? Because we have more than 1,800 or something. Very, very fast, so probably you don't need even that. But yeah, feel free that it will take just 0.5 or 0.7 milliseconds per one frame. At the same time, when we look at the GPU usage, you can see that it's 100%, like we are just using this GPU. At the same time, CPU usage is rather low, so we can use CPU for something else. And looking at the power consumption, it's about 27. So not only better performance, but also less power consumed. So I think it's even better than simple CPU, right? And this GPU is already integrated on the same chip. So when you buy a CPU, you have the GPU already there. But we can go even better. Let's switch to the NPU. NPU, Neural Processing Unit, our new device, and let's run it once again. And right now we have, let's wait for the startup a little bit, almost the same, 1,000, 1,500, depends, right? 1,200, 100, something like that. Similar, I think it's good enough. The result is good enough for many cases, for almost all cases. When we look here, we can see that GPU is no longer as heavy used as before, but right now we can see NPU is used for that. Yeah, it should be here in 3D. And then let's look at the power consumption as well. And look at this. Right now we are running on 1918 watts. So this is low power device. Still, almost as good as GPU in case of performance, much better than CPU, and lower power, right? So you don't use your battery so much, so your battery will last for longer. This is super cool, I think, right? Isn't it? Okay, good. So this is what I wanted to show you. Let's go back to the... Oh, I need to switch again. Yeah, so what we already presented to you, it was large language model demo. There is a QR code in the corner if you would like to try at home. Everything here is open source. So you can go to our GitHub, you can download this model, download this demo and run on your computer. If you have Intel or ARM device, because we officially support ARM, you are able to run it. So this was the first. I can see still people taking photos, so I will pause for a moment, just a moment, of course. And don't worry, I have even more QR codes. Much more. Okay, so the second slide, I also showed you object detection. So it's also available there in the same repository, but this is specific QR code for the object detection. Then post estimation, action classification, everything like these models can be run with either CPUs, GPU, or NPU. So yeah, feel free to test all of them if you have access to them. Of course, if you have older CPU without NPU, no problem. We support also older CPUs. So yeah, just feel free to try them. And we have also that all of these notebooks are in our OpenVINO notebooks repository. So this is the final code to the main repository itself. So there are more than 150. Not all of them could be run on all devices right now. For example, GenAI should be rather run on GPU instead of NPU and everything like that. But we are working on this to support it better. But yeah, so some of them, three devices, but some of these notebooks just CPU or GPU. But anyway, it's worth a try. So I hope we already proved that local inference is possible with that kind of devices, and you don't have to buy any discrete cards, you don't have to rent a cloud, you don't need to send any data anywhere. And yeah, just try it. Don't believe us, just try it. That's all from our side.
Thank you, super nice. And I always love the live demos, and they actually went well.
Yeah.
All of our live demos today went well, so that's really awesome. Are there any questions from the audience? We have some time left. I see one there and one there in the front.
Hi. Are you also thinking of working on optimizing training?
So OpenVINO is for inference only. OpenVINO is not planned to be for training. If you would like to use Intel hardware for training, we recommend you to try Intel extensions for TensorFlow or Intel extensions for PyTorch. There are packages like these.
Okay.
It's going to be a bit controversial, but OpenVINO also supports the AMD architecture?
Yeah, it's a controversial thing. But we don't officially support it, but it's the same architecture of the processor, right? So it should work. But I say it should, because we don't officially support it.
And we don't know how good.
Yeah, also. We are sure that for Intel works good. You know.
We saw some talks today about retrieval augmented generation. Is that something you can talk about in the context of OpenVINO and the NPU? How would that perform?
Yeah.
I can answer that. So we know that RAG is a very important use case, and especially if you work with your corporate data, you would like to utilize LMs to get better access to this data. And OpenVINO supports RAG, so we have an integration with LangChain, and so it works perfectly. And basically, we recommended you already to use some OpenVINO notebooks, but on the same page there is a notebook to demonstrate how RAG works with OpenVINO. So basically it looks the same as a chatbot, but you have additional fields to add your documents in any format, like PDF, doc, HTML, whatever, and you can communicate with this database and build your application on that.
We have one more question.
Thank you. You also talked about this new processing unit, the neural processing unit. Is there like a plan of this being available in all Intel chips in the future, or is that specific types of chips? What fraction of computers do we expect in the future to have these chips built in?
So right now it's available only in Intel Core Ultra series. I don't know about the future. I think it will be only Core Ultra.
Yeah, so it's a current generation under Intel Core Ultra, so the code name is Meteor Lake, but Intel has already announced some, I think, month ago that a new generation will be released. It's Lunar Lake code name, and it will have NPU as well, and also with huge performance. It will be, I believe, 45 tops.
4 times more than we have right now.
Exactly. So NPU is an important part of the compute for the PC. So this is what we can, let's say, share about that.
Nice. Awesome. Thanks for all the good questions. I think you can also find them so at the Intel booth if you have more, or if you want to have a cool demo of creating your own sticker with Stable Diffusion. So
Yes.
give it up one more time for Adrian and Dmitriy.